Good morning, everybody. How are you all? Okay. So today's class we are going to study about the sound, the chapter related to physics here. In this chapter we are going to study what is a sound and how the sound propagates, the propagation of sound through the medium, and how the sound will be produced, the produce of sound, and what is the reflection of sound, and all we are going to study here. So first, how we can produce the sound. Okay, so here in everyday life, sound plays very important role. Okay, so here sound is nothing but it is a form of energy. Sound is a form of energy, and energy it means there are different types of energy are there. Light energy is there. Okay, the next in the last class means in the physics last chapter, that is work and energy. There we have studied about the different types of mechanical energy, that is the potential energy, kinetic energy. So and also we have studied about the law of conservation of energy. The energy neither be created nor be destroyed, but it can be transferred from one form to other form. Okay. So here the sound, it is a form of energy, means it will we can produce the produced sound is nothing but it will be transferred from one form to the other form. If we clap, okay, if you clap, then you can hear the sound. Okay, so sound it is nothing but it gives the hearing intensity, the hearing capacity, or it helps for the hearing. Okay, and here the how we can produce the sound. Usually, when the vibration, when the objects get vibrate, then also we can produce the sound. The vibration of materials produce the sound. Okay, just here the stretched rubber band. Okay, when you pluck it, there is a vibration takes place. Okay, so vibration produces the sound. Okay, so here how the sound will be produced? By rubbing your hand, you can hear the sound. It means sound will be produced. Okay, so here there is one activity. If it clarifies the vibration and the production of sound. Take one tennis ball, and here just fix it with one iron rod. Then here take one tuning fork, So here when this tennis ball hits the tuning fork, when it hits the tuning fork, then it starts vibrating. Okay, when it starts vibrating, you can hear the sound. It means, or even you can take one rubber pad and hit the tuning fork. When the tuning fork starts vibration, you can hear the sound. It means, how the sound will be produced? The sound will be produced by the vibration. Okay, by the vibration of the objects, sound will be produced. And even by rubbing your hands. Okay, also there is a production of the produce of the sound. Okay, the sound produced by this activity. It is a very simple activity. Okay, when the ball hits to the tuning fork, usually the tuning fork starts vibration, and with the vibrating, when it starts vibrating, then we can hear the sound. Okay, the next after this, the sound. Actually, the sound is a longitudinal wave. The sound is a longitudinal wave. Means it is in the form of a wave. Okay. Sound is a longitudinal wave. Okay, so here the sound, it is in the form of wave. What do you mean by wave? What is a wave? Wave is nothing but it is a periodic disturbance in the medium. The periodic disturbance in the medium is called as a wave. Okay, so the wave consists of a trough and crust. Okay, the upper part that is called as a crust and the valley that is called as a trough. Usually the wave, consider one wave. Okay, here in the wave, so it is called as a crust. This is called as a trough. So the distance between two consecutive crusts or two consecutive troughs is called as a wavelength. Wavelength is denoted with the lambda. Okay, just here when you study about the wave, so wave is nothing but the periodic disturbance. The periodic disturbance in the medium is called as a wave, and here the upper part, that is the crest, and the valley, that is it is called as a trough. Okay, the lower part that is called as a trough, and here the wavelength. About the wavelength, so wavelength is nothing but what is the definition of wavelength here? Okay, so wavelength usually is denoted with the lambda. The distance between two consecutive crusts or two consecutive troughs is called as the what? The wavelength. Okay, wavelength, it is denoted with the lambda, and the unit of wavelength is a meter. Okay, how we can measure the distance with the help of the meter. So that's why the SI unit of wavelength is a meter, and the symbol of the wavelength, or it is denoted with the lambda. So what is the wavelength here? What is a wave and what is a wavelength? Wave is nothing but the periodic disturbance in the medium is called as a wave, and wavelength is nothing but the distance between two consecutive crusts or two consecutive troughs is called as a what? Wavelength. And here the next one is to the wavelength. The next one is the time period. So time period means what here? It is denoted with a capital letter T. The total time taken to complete one oscillation is called its time period. So what is the time period here? Time period is nothing but the total time taken to complete one oscillation. That is the one trough and one crust. That is called as what? The time period. Time period is denoted with a capital letter T. It is denoted with a capital letter T. And here after this we have to study about the compressions and rarefaction. So waves. So sometimes what happens, wave, they are very closer. So see here the waves. If the waves are very closer, so this is like this. So these are called as the compressions. See, and sometimes they are further apart. So these are called as a rarefaction. So what both are waves, but here compressions and rarefaction. Rarefaction means the waves are very closely. If the waves are very close, then it is a compression. If the waves are further distance or further apart, so that is called as a rarefaction. Okay, so both are waves only. They are having the crust as well as the trough. Okay, so the compression and rarefaction. If you consider one wave, okay, here, so this is very near, it is called as a compression. The apart, there is a gap, so that is a rarefaction, compression, rarefaction. Okay, so here the compression and rarefaction togetherly, that is a formation of a sound or the waves, the sound waves or the waves, the periodic disturbance in the medium. Okay, so after the compressions and rarefaction, then the term related to the wave, so that is nothing but the frequency. So next we have to study about the frequency. So what is the frequency? Okay, see here. What is the frequency? the number of oscillations per second means the number of one thrust and one trough, that is called as a per second, that is called as a frequency. So frequency is nothing but the number of oscillations per second is called as its frequency, and depending upon the frequency the sound pitch is high and less. Okay, the frequency settlement or the frequency usually because of the frequency, if it is frequency high the pitch is high, if the frequency is low then the pitch of the voice, that is will be less. Okay, so depends upon the what frequency. So that's why here the frequency is nothing but the number of oscillations per second. Okay, so number of oscillations per second, and frequency usually the SI unit of frequency, SI unit is hertz. The SI unit of frequency is hertz. You can to frequency means 2 hertz. The SI unit we are using as a hertz, or you can write Hz. So this is a 1 hertz, 2 hertz, like this. 1 Hz means 1 hertz of frequency. So what is the frequency here? The number of oscillations per second is called its frequency, and the SI unit of frequency is a hertz, Hz. Okay, hertz, and here the frequency and time period. Usually the time period and frequency, they are having the relation between the frequency and time period. Okay. Okay, see here frequency nu, okay, is equal to 1 by t. So this is the relation between the frequency is equal to 1 divided by time period. 1 divided by time period. It means here the frequency, already you know the definition of frequency. What is the frequency here? Frequency means the number of oscillations per second is called its frequency. What is the time period? The number of oscillations means the time taken to complete one oscillation, that is called as a time period. And frequency, it is denoted with the nu, and time period with the capital letter T. So that is the frequency is equal to 1 by time period. This is the relation between what? The frequency and the time period. Okay, so if you want to calculate time period, if you know the timetable, you can write the frequency also. It means number of oscillations per second is called its frequency. Okay, so the term related to the wave, that is a thrust, trough. Okay, the next amplitude. So what do you mean by amplitude? Or amplitude is nothing but the height of the wave. So just here, take one wave. So here, so this is called as a crest, this is called as a trough, and this height is nothing but this is called as what? The amplitude. The amplitude. So amplitude is nothing but the height of the wave or up to the crest or trough. So that is considered as a what? Amplitude. So next, the distance between these two is called as a wavelength. Wavelength. Usually the wavelength is denoted with the lambda. So lambda, and the SI unit of wavelength is a meter. The SI unit of wavelength is a meter. Okay, so see here the relation between the frequency and the time period is nothing but V, that is nu is equal to 1 by time period, or the frequency is equal to 1 by time period. So this is the relation between what? The frequency and the time period. Okay, so here just I will revise once again here. Just here sound. What is the sound here? Sound is nothing but it is a form of energy. It is one type of energy, just like a light energy or mechanical energies. Okay, already in the last we have studied that mechanical energy, kinetic energy, and potential energy. They are the types of energy. Like that, sound is also a type of form of energy. And energy in the means energy can neither be created nor be destroyed, but it can be transferred from one form to other form. Like that, sound will be produced by the vibration. Okay, by the vibration of when the object is vibrating, then we can hear the sound. Okay, sound is produced by the vibration, and also sound will be propagated you can hear the sound with the help of the air. Okay, actually there is a one experiment. Air is necessary for the propagation of sound, but now it is a deleted. Okay, the portion is deleted, that is a medium. So the sound through the medium, like sound propagation, the propagation of sound through the medium like air, water, solid. Okay, usually sound will be produced and it will be propagated with the help of what? The medium, air medium. Whatever the sound we are hearing, that is with the help of the air. So air plays very important role for the propagation of sound. In that there is one experiment, the jar experiment, but now it is a deleted. You should take one bell jar and keep one and it is attached with one vacuum pump. Then with the help of the vacuum pump we can remove all the air inside the bell jar. The bell jar, the top of the bell jar, it is closely packed and connected with one electric switch. When you on the electric switch, the rings starts the ring. Its electric bell starts the ringing. You can hear the sound. By removing the air which is present inside the bell jar with the help of what? The vacuum pump, even though the bell is ringing, but you can't hear the sound. When you push the air inside the bell jar, again you can start the hearing the sound of the bell, electric bell. So it means that the sound, it is propagation, the propagation of sound by the air. Okay, like that the sound will be produced and sound will be propagated. When the sound is produced, it will be propagated with the help of the air. Air plays very important role. Okay. The next, after that, the propagation of sound. So the next one is here the sound, reflected sound. So about the echo and all, the chapter is related, but you should know that what is the echo. Echo is nothing but the reflected sound is called as the echo. You can hear the sound, the same sound 2-3 times or more than 100, more than 2 times. That is called as the echo, multiple echo, and that is nothing but the distance. At least the distance between the sound producer and the object, reflecting object, should be 17 meter. So that is the echo and how the formation of echo and all. Okay, but here for your syllabus, that is only we have to study about the wave and propagation of the wave and the nature of the wave and the compression, refraction. Here, when we consider the compression, when we consider the wave is nothing but the periodic disturbance in the medium, and here the wave is having it's the longitudinal wave. Usually it is having the crests and trough. The upper part, that is the peak of the wave, is called as a crest. The valley of the wave is called as a trough, and togetherly one crest and one trough togetherly called one oscillation, and the distance between two consecutive crests or two consecutive troughs is called as a wavelength. Wavelength is denoted with the lambda, and the unit of wavelength is a meter. The SI unit of wavelength is meter, and number of oscillations per second is called what? It is the frequency. So frequency is denoted with nu, and frequency is the SI unit of the frequency is hertz or Hz. So that is the hertz. Okay, and the relation between the time period and the frequency. First you should know what is the time period. The total time taken to complete one oscillation is called as its time period, and the time period and the frequency both are having the relation. So the relation between the time period and frequency is nothing but that is the frequency is equal to 1 by time period. Okay, so this is the relation between frequency and time. If the time period is given, easily we can calculate the frequency by using this formula. Frequency is equal to 1 by time period. Okay, the next after that, amplitude. So the height of the wave, so that is called as the amplitude. And now we have to study about the low pitch and high pitch. Okay, so here there is one diagram. We will draw the diagram just here. Okay, so next here the sounds with the different sounds. That is this waves shows the sounds, different types of sounds, means the soft sound, louder sound, okay, and the high sound, and for a low sound. Okay, just here the wave shaped for a low pitched sound. Low pitched sound. Just see the comparison between these two. Okay, so here the sound's amplitude is higher, amplitude and wavelength. So here when you consider the wavelength between these two, what is the distance between these two crusts or troughs? So that is called as its wavelength. When you consider the wavelength, the distance between these two, it is very less. If the wavelength is less, then the height, that is the speed of the sound is high. If the wavelength is more, the distance is more. Okay, if the wavelength is more, then it is the sound is pitched. The sound is the pitch. It is the low sound pitch. It is okay. For a high sound pitch, the wavelength is more. The wavelength is more. For a low sound pitch, the wavelength is a longer distance and the wavelength is a shorter distance here. Okay. So the next step. So this shows that soft sound and a louder sound. Okay. So here soft sound means the amplitude. It depends upon the amplitude and the frequency. Okay. So amplitude also depends upon the sound. It's a soft sound and the louder sound. Whatever the sound is produced by the human beings. Now, whatever the sound you are hearing, how you can produce the sound? By our vocal cords. Okay, in the vocal cords there are C-shaped rings. Already I explained in the bone and cartilage. Okay, the cartilage is the connective tissue. Actually, C-shaped rings which are present in the vocal cords. Okay, while talking, just put one hand or one finger on your throat. You can feel that there is a vibration. Okay, the vibration. So that vibration produces the sound. Okay, that vibration produces the sound, and that sound will be propagated. Okay, with the help of what? The air. Okay, the sound will be propagated with the help of air. In vacuum, the sound will not propagate. The sound will produce, but it will not be propagated from one place to the other place. Okay, in our sound is produced by the vocal cords. In our vocal cords, by vibrating the C-shaped rings, that is the cartilage. When that vibrates, we can produce the sound. The sound again, the high pitch sound and the low pitch sound. Okay, so the high pitch sound. So high pitch sound is nothing but here the amplitude and the high amplitude with the wavelength. The wavelength is a shorter wavelength, but here the wavelength is a longer. The long distance wavelength that produces the low pitch sound. The less sound will be produced. So these are what the different types of the waves. It shows by the graph of this or by the diagram of the wave. We can easily identify the pitch. Either it may be low or it may be high. Okay. The next, after this, here this sound, the applications of sound and ultrasound and all. So usually the hearing capacity of sound. Usually in the man, the hearing capacity, we can hear the sound. The audible range of man. So what is the audible range of man? 20 Hz to 20,000 Hz or 20,000 Hz. So that is nothing but the audible range. You can hear the sound. Okay, the audible range means if you want to hear the sound, if the sound produced, if it is very less frequency or it is very less frequency, then you can't hear that sound. Even our ears, means the structure of ear, here the hearing capacity, that is our ear is having hearing capacity when the sound vibrated or when the sound it reaches to our ear, identify the sound. Okay, the next step, the sound it is pleasant to hear. The sound is pleasant to hear, then it is called as a music. If it is unpleasant to hear, that is called as a what? The noise. Okay, so you people are very feeling happy to hearing the music, not the harsh sound. Okay, the harsh sound it disturbs our mind. Okay, but here the music and sound both are sound. The music and the harsh sound both are sound, noise and music, but their frequency, depending upon their frequency, if it is pleasant to hear, then it is called as a music, and if it is unpleasant, then it is called as what? The noise. Okay, noise pollution and all. The noise pollution is nothing but the sound pollution. The sound pollution means the loudspeakers, the high pitch loudspeakers, and the automobile sound, okay, and the borewell sound. These are the noise and it disturbs our mind. So that's why the noise and the noise pollution, as much as possible we should avoid the noise pollutions. Okay, so this is about what the sound. Okay, the next one after this we are going to study is a one formula to calculate the speed of the sound. Okay, the speed of the sound. What is the speed of the sound here? The sound speed. Okay, there is a one formula, that is the speed is equal to distance or the wavelength. Distance means here the wavelength divided by the time taken. Okay, so here the distance is nothing but the wavelength divided by so the formula to calculate the speed of the sound. So that is the V means the speed of the sound. So here speed is equal to distance divided by time. Okay, so distance is nothing but here wavelength. Wavelength is the lambda divided by time means t. Okay, so here wavelength, already we know that we studied about the wavelength. What is the wavelength? The distance between the two consecutive troughs or two consecutive crests is called as what? The distance. And distance we can measure with the help of the SI unit, that is a meter. Meter is the SI unit of distance. And here frequency, about the frequency also we have studied the SI units and the definitions. Just here about the some terms related to the sound here. First one, you should know about the wave. So what is a wave here? Wave is nothing but the periodic disturbance in the medium is called as a wave. Okay, what is a crust here? So crust is nothing but the peak of the wave. The peak of the wave is called as a crust. The next, what is a trough here? Trough is nothing but the valley of the wave is called as a trough. Okay, and the crust and trough means the number of here the distance between the two consecutive crusts or two consecutive troughs. It is called as what? The wavelength. Wavelength. What is the wavelength here? Wavelength is denoted with the lambda. So wavelength is nothing but the distance between the two consecutive crusts or two consecutive troughs is called as its wavelength. Okay. So what is the wavelength here? Wavelength is nothing but the distance between the two consecutive crusts or two consecutive troughs is called as a wavelength. And next one is a amplitude. So what do you mean by amplitude here? Amplitude means here the height of the wave, up to the height of the wave or the height of the crust or trough, that is called as amplitude. Okay. The next, up to that, frequency. What is frequency here? Frequency is nothing but here the number of oscillations per second. The number of oscillations per second is called its frequency. And the SI unit of frequency, the SI unit is okay. So here the SI unit of frequency is hertz. Hertz is the SI unit, and here the SI unit is a meter. So meter is the SI unit. Okay. So here the frequency. What is the frequency here? Frequency is nothing but the number of oscillations per second is called its frequency. And the SI unit of frequency is the hertz, and frequency is denoted with the nu. Okay. The next time period. Time period. So what is the time period here? Capital letter T. So time period is nothing but the number, the the time taken to complete one oscillation. The time taken to complete one oscillation is called as a time period, and there is one relation between the time period and the frequency. So that is the time period and frequency. Frequency is equal to 1 divided by time period. 1 divided by time period. So this is the relation between what? The frequency and the time period. Time period is nothing but a t, and frequency is nothing but nu. And the estimate of time is here seconds, and the estimate of frequency is nothing but a hertz. Okay, so here what is the wave? Wave is nothing but the periodic disturbance in the medium is called as a wave. Crest, the peak of the wave is called as a crest, and the valley of the wave is called as a trough. Wavelength, the distance between two consecutive crests or two consecutive troughs is called as a wavelength. Wavelength is denoted with the lambda. Lambda it is, and the SI unit of wavelength is a meter. The next, amplitude, the height of the wave, that is called as a amplitude. Frequency is nothing but the SI unit of frequency is hertz, and frequency is the definition is number of oscillations per second is called as a frequency. And time period, the total time taken to complete one oscillation is called as a time period. The relation between the frequency and time period is a time period or frequency is equal to 1 by time period. And here the formula to calculate the speed of the sound, that is the distance here, that is nothing but a wavelength divided by time taken. Wavelength is nothing but the extent of wavelength is a meter, and the time is nothing but seconds. Okay, so this is what the sound chapter. In this chapter, actually the propagation of sound. The propagation of sound, air is necessary for the propagation of sound. The Elshar experiment, reflected sound, that is called as echo, and the next one, the applications of what is ultrasound, and the application of ultrasound, hearing capacity of the man, and the structure of ear. These all portion is deleted. Okay, only this much portion for your syllabus, and just write this notes and write the question answers. Only this much only. Okay, thank you.